Hey guys, this looks like a fun exponent problem from the United Kingdom Mathematics Trust. How many different real number solutions are there to the following equation? X squared minus 8x plus 15 to the power of x to the 5 minus 5x cubed plus 4x equals 1. With many powers within powers, be careful to count solutions only once, and importantly, ensure you haven't missed any solutions in your final answer. If you want to have a go on your own, pause the video here because I'll start solving it in 3, 2, 1. The base and the power itself seem chunky to deal with. Let's neaten it up with some algebra. If we let a equal the base, x squared minus 8x plus 15, and b equal the power, x to the 5 minus 5x cubed plus 4x, the equation can now read a to the power of b is 1. We now need to just consider the values for a and b such that a to the b is 1, getting rid of the messy polynomials for now to get started with our problem solving attack. Keeping a and b at the top right, one case is when a is 1. Whatever the value of b, 1 raised to the power of anything is just 1. Another set of solutions occur when b is 0, as anything to the power of 0 is again just 1. Be careful though of when a is 0 as well. While in some contexts 0 to the power of 0 is 1, it's typically left undefined, and so solutions won't occur when both a and b are simultaneously 0. Perhaps the slightly trickier case is to see at first glance is when a is minus 1. As long as b is an even number, minus 1 to the power of b will always be 1 as well, so some solutions could occur here too. Now we have our three cases of when a to the b is 1 at the top, we can start looking at a and b in their normal forms to find proper solutions. For case 1, we need to find how many solutions there are to a is equal to 1. That is, x squared minus 8x plus 15 is 1. Subtracting 1 from both sides gives x squared minus 8x plus 14 is 0. Completing the square gives x minus 4 all squared minus 2 is 0, which means x is equal to 4 plus or minus the root of 2. These are two unique solutions for when a is equal to 1. Let's keep this at the top. Next, when looking at when b is 0, that is when x to the 5 minus 5x cubed plus 4x is 0, we can factorize out the common x between all terms. X to the 4 minus 5x squared plus 4x can be factorized into x squared minus 4 and x squared minus 1. Each of these brackets can be separated further by the difference of two squares to give in total x, x plus 2, x minus 2, x plus 1, x minus 1 is equal to 0. This means x can take 0, negative 2, 2, negative 1 and 1 as solutions to make b is equal to 0. We also need to check that none of these solutions makes a equal to 0 as well, and quickly substituting in these solutions of x into our equation for a shows that this is not the case, so all 5 of our solutions are correct. Finally, we can look at case 3, when a is minus 1 and b is even. I think the best way to check what values of x makes a is equal to 1, and then check if these values of x make b even. We have a as x squared minus 8x plus 15 is minus 1. Add 1 to both sides and we get x squared minus 8x plus 16 is 0. We can spot that 16 is a square number, and so the factorization x minus 4 all squared is equal to 0 works, giving a repeated root of x equals to 4. This is the only solution to a is equal to negative 1. We now need to check if x squared x is equal to 4 makes b even. So plugging 4 into all of our x values gives 4 to the 5 minus 5 lots of 4 cubed plus 4 lots of 4. From here we can factorize further or simply evaluate each term to get 720 as the answer. 720 is even, so x equals 4 is a valid solution. Our third case gives one solution. In total, when we add up each solution, which are all unique to our original exponent equation at the start, x squared minus 8x plus 15 to the power of x to the 5 minus 5x cubed plus 4x equals 1, we have 8 solutions. 8 different real number solutions is the final answer. I hope you enjoy this one, a tricky exponent within an exponent problem, where it might be quick to see the first few solutions but promotes the logical, algebraic breakdown of steps to count all solutions. Beautiful. Thanks for watching Beat the Calculator. See you next time for more logic and maths fun.